Hello friends. So somebody asked me what are the different types of chemical bonds, and I started wondering, are all different bonds the same? Are all different cricket players the same? No, we have batsmen, bowlers, wicket keepers. So not all cricket players are same. How come we have more than 100 different elements, and when they form bonds together, will they be the same? Obviously no. So when we study that atoms try to form an octet, which was the concept given by Lewis, that is, they try to attain noble gas configuration. So sodium and chloride, sodium has one excess over noble gas configuration, chloride has one deficient. Sodium can give over an electron to chloride to form sodium can get a stable octet, chloride gets a stable octet. So we have a positive charge here created, you have negative charge created, and they can be held together closely by what is called electrostatic forces or Coulombic forces. So here we see this is an example of what sodium chloride looks like. Chloride ions are surrounded by sodium ions, and sodium ions are surrounded by chloride ions, and this intermixing gives rise to a very strong thing, what we call salt, which is very high melting, and if we melt it, then it becomes a good conductor of electricity too, and it is hard. However, let's take the case of water. In water we have one oxygen atom and holding two hydrogen atoms at an angle. And where does this angle come from? This angle comes from the overlap of orbitals. Oxygen sp3 orbitals overlap with hydrogen s orbitals, and they together share these two electrons, forming one bond. This is called covalent bond because there is sharing involved. As we can see in this slide, the bond is formed by sharing an electron pair between one atom of A and one atom of B. Now the electrons can be an A in one time and electron of in B in the other, and they can interchange these places. This gives rise to two equivalent structures, and this is the basic concept of valency bond theory, or resonance between structure giving rise to a bond, a chemical bond. This concept of resonance can be further extended to multiple atoms. So in benzene, these shared electrons move about over the entire benzene ring. Similarly, very long linear molecules also can have resonance. For example, beta carotene or vitamin A is having very long chain in which this electrons keep moving about, and this gives rise to the color of vitamin A or beta carotene. So what happens when this sharing is involved? Now oxygen is very strongly electronegative while hydrogen is somewhat electropositive. So oxygen will try to pull the bonded pair towards itself. Oxygen acquires a delta minus charge and hydrogen acquires a delta positive charge. So we get a dipole, that means the bond is partially ionic. This is a covalent bond but with a partial ionic character, and this what we have two poles, one positive and negative poles created, which is called a dipole, and this dipole interaction between the different molecules give rise to somewhat weak forces between the molecules. So these molecules are not so strongly held, and therefore since they are not so strongly held like ionic, they can have it's easy to break them apart. So they have low melting points, low boiling points. Water is liquid at room temperature. H2S and ammonia are gases at room temperature. Nitrogen is a gas. So this type of bond is called covalent. And again, covalent between, when there is a strongly electronegative atom involved like oxygen and hydrogen, then what can we can have what is called hydrogen bonding. So hydrogen bonding keeps water liquid at room temperature. Even it is somewhat weakly present in ammonia also. And between our DNA, in our RNA, this hydrogen bonding plays a very strong role in making structure of what we exist and other animals and plants exist in their life forms. Coming to hard metals, these hard metals like say steel, it's a good conductor of electricity. Copper, silver, gold are still better. So they're again a different type. Again things are held together almost like an ionic solid in a fixed lattice structure. However, the outer electrons are moving around freely over the whole framework. It's like metal ions are immersed in a sea of electrons, and therefore they become very good conductors of heat and electricity. However, because of their strong bonding, they are also very strong, malleable, ductile, and have very strong mechanical strength. So you have steel, aluminium, titanium, and very strong things involving metal alloys, right? So these are basically three colors. So we got covalent bonds, we have got ionic bonds, and we have got metallic bonds. Again, in covalent compounds we also see what is called hydrogen bond, as well as other types of weak forces which are called van der Waals forces. So basically what happens, every atom has a nucleus which is positive charge and a cloud of electrons surrounding it. So amongst these two atoms, when they come together, the negative cloud electron of one atom attracts the positive of the other atom, and then they try to come together, and when they are still trying to come too close to each other, then nuclear repulsion may start predominating, so they remain at a certain distance called the internuclear distance. So between the internuclear distance, from the internuclear distance we can get what is called the atomic radius. So the bond length is the internuclear distance, or the distance between the nuclei of the atoms that are forming the bond. Similarly, bond energy is the energy that is released when this bond is formed, or otherwise bond energy is the energy required to break apart the bond, break the bonded molecule into individual gaseous atoms. So we came to know something about bonds. So now if you look objects around you, say you hold a metal spoon or a gas cylinder, what type of bond does it have? Obviously metallic bond. If you see the cooking gas, liquefied petroleum gas, that is propane and butane, what bonds will it have? Obviously they are volatile, ready to escape, so they can't be ionic, can't be metallic, they are covalent compounds. Carbon dioxide as a gas is having covalent bonds. And coming to ionic bonds, not just sodium chloride but most of the metal ores, the sulfide ores, the oxide ores, what you extract from the earth, all are having ionic bonds which may also have some partly covalent character. So thank you very much. I hope you got to know what are the different types of chemical bonds.